do it. All right. Okay, so first question, get a sense from you guys. Second here, hide, all right. So let me go to you, Josh. Protocol, what do you understand by protocols? Just when you hear the word protocol, anything comes to mind?
Yeah, like sending and receiving. You have the like the NIC protocols.
No. Don't. Just the word protocol in general.
Oh, protocol, like procedure.
Exactly. In general, it's like a what?
Like a standard operating procedure.
Okay, so give me an example of a protocol. Like, let's say, like related to driving, for example. Are there some protocols or procedures one has to, like what?
Look both ways.
When you're driving, you got to look both ways?
When you're turning, you got to look both ways. You know, turning outside of your driveway, backing up, got to look both ways.
Okay, that makes sense, right? You don't want to kill somebody.
Bikers are out now.
Okay. What about, let's see, Will, what kind of protocols might you need to observe or procedures, I don't know, like an office environment, like at work?
Like you got to do certain things in order to like get into your office. Maybe you have like PIN code at the front door, or like there's a security guard you got to go past. So like you'd have to do certain things in order to gain entry to the building.
All right. So for example, if you walk in that building, who will know what those protocols are? The people who work there, or like the general public?
Just the people that work there.
Okay. All right. Now let me ask one more question. This might be a funny one this time, Winston. So what kind of protocols are there when you're in a Zoom class compared to a regular class, like a face-to-face class in person? Any protocols, procedures?
For in class, like in physical class?
Like in the Zoom class, like this class. Are there any unique protocols that we have to observe?
To answer your questions, if you call on us.
Okay. What else?
We have to make sure our background noise is quiet.
All right. So generally, people want to like mute and unmute and things like that, right?
Yeah.
All right. So all this. Go ahead.
No, I was just saying.
All right. So why all this? You know, why protocols? You might think about it like protocols help things stay organized, right? Like when you're on the road, you're trying to back out of a driveway, you get to an intersection, you know, you get to a rotary or a roundabout. You know, you got to know who goes in first, who goes in next, or else there's going to be a lot of accidents on the way. When you see traffic lights and the light is it's red, or it's, you know, you got to know how to observe, understand the protocols, observe, obey the protocols, right? If you don't obey the protocols, things might not go so well. If you get to your building and the security person says, "Can I see your ID?" and you're like, "I work here. I don't have to show you an ID." Says, "Can I see your ID, sir?" "No, I work here. Don't you know me? I'm not showing you an ID." You can be sure there's going to be a lot of trouble, right? So follow protocols, the established ways of doing things. Now, in networking, we certainly have protocols that we have to observe. Now, let's go on here. It says here that protocols are, just like you said, rules and behaviors rules and behaviors. They're rules, they're procedures for communication, right? Basically, computers and computer systems have to be able to speak, the same language, so they can understand each other. Traffic or data can flow from point A to point B as we expect, so that things can be done the way they're supposed to be done. Now, these protocols are a lot. There are a lot of protocols, and this, like, we have a couple of names for these protocols. Now, we're on page 224 and 225. On 225, we see there that it talks about a protocol suite, right? Transmission control protocol, right? Transmission control protocol / internet protocol. That's where you get your IP address from. Now, the transmission control protocol / internet protocol are they're made up of quite a lot of protocols, but we're kind of going to group them together, shall I say? So we see the table, and this first table you might remember this from chapter 1 and 2, where we talk about the different layers of communication. So we see this table with 4 layers, right? This is what you mean by the transmission control protocol / internet protocol, right? In fact, we have 2 types of, should I say, architectures or systems when we talk about the different layers, right? You have the TCP/IP layered architecture, and you have the OSI model. The TCP/IP is made up of 4 layers. Right, these are terms you're going to hear about, and even in your assignments, and in the whole of IT. When you talk about TCP, you're talking about application layer, transport, internetwork, and network access. It's like 4. The OSI model is made up of 7. It's like a bit broader, right? It's made up of 7: application, presentation, session, transport, network, data link, physical. All these layers are responsible for, communication in a lot of different ways. And let's take a sneak peek into some of these here. So the TCP/IP layers are 4 layers: application, transport, internetwork, and network access. Now, each of these layers have protocols that operate on those layers. So to the right, you can see you have protocols that operate for application, protocols for transport, protocols for internetwork, and network access. Back in the book, we go to page 226, right? Now, page 22. I'm going to go into details here, but let me just, let's just kind of talk about a few things here as we go along. Now, one of the first things you want to know about the different protocols. Now, you see that to the left here, you see the OSI model. It's made up of 7 layers. And you have the TCP/IP model, which is 4 layers. So basically, application on the TCP corresponds to application, presentation, and session on the OSI model. Transport is the same on both sides. In the TCP/IP, you have internet. In the OSI model, you have network. OSI model, you have the link and physical. Well, this is a bad spelling here, right? Physical, why? Physical, link and physical. On the right side, you have network access. So when you do a kind of like a comparison, they are kind of similar, but of course, the OSI model is more expanded. All right, so here are things for you to be aware of, right? On the application layer, TCP/IP or application, presentation, and session, what we refer to as data, right? Data, information. When you're at the application layer, that data or information or message is simply called data. Now, you should understand that when we talk about these sessions, your data flows from top to bottom. So your data starts at the application layer, it goes down to transport, goes down to internet, goes down to network access. If you're in the OSI model, it starts from the application layer, it goes down to presentation, then it goes next to session, transport, network. Your physical layer is where you have your Ethernet cable and fiber and all the different media or mediums of communication. The physical, mostly the physical cables and stuff, electricity, things like that, at the physical layer. So back to the application layer, your data is called data, right? That's the name. It's referred to as simply data. Let me see something else here. Yeah, so it says right there on page 226, right? The unit of information at the application layer is simply called data. A unit of information is called data, okay? And so what do we mean by the application layer here, right? We're going to go into that detail. So your unit of information at the application layer is referred to as data. When that data keeps moving down the line from application to transport, or from the application, presentation, and session down to transport on the left side, the unit of information changes its name from being called just data to being called a segment. And we see that on page 226. The unit of information at the transport layer is called a segment, or what? Is anybody seeing that? Page 226?
Datagram?
It's called a segment or what?
Datagram?
A segment or datagram. Exactly. Now, there are two protocols. We're going to go into a bit of detail, but there are two protocols on the transport layer. On the application layer, you have like a bunch of protocols, like a lot of them. But on the transport layer, you've got just two. Now, depending on the protocol that is at work, your protocol, your data or your unit of information might be called a segment if it's using TCP, and it's called a datagram if it's using UDP for transportation. When I'm talking about transportation or transport, is basically how the data is carried. How it's carried, move from point A to point B. Just like if you wanted to send a package to, you want to send some kind of mail, right? Or an application for a scholarship or some, financial benefit or something, right? You might decide, well, I'm not going to put this in the regular mail in those blue boxes. I want to be sure that it gets there. I want to get a tracking number and stuff like that. So I am going to register that mail. It's kind of like it's comparable to what happens at the transport layer. They're kind of like two ways of transporting your information. It might be TCP or UDP. If it's UDP, your data is referred to as a datagram, or your information is referred to as a datagram. If it is going with TCP transport, it is referred to as a segment. You got to absolutely be clear of all those terms especially when you're doing your assignment, and if you find yourself, in front of a very detailed interviewer at an internship. They might ask you a couple questions just to see where you're at. What kind of IT student you are. Now, when your unit of information comes down to the network layer, it now is referred to as a packet. If you guys remember from our conversations in the past, a packet is information or is data that includes an IP address. So once your IP address is attached to that data, its name now becomes a packet. Going down the line, when that information goes from the internet layer down to the network access layer. It picks up a MAC address. The name is now a frame. It becomes a frame. So your data moves from your unit of information, should I say, starts out being just data. At the transport layer, it's either a segment or a datagram. At the network layer, it becomes a packet because it now takes on some IP addresses or an IP address. Then it gets a MAC address and now becomes called a frame. So all these terms might be used. Sometimes people just use them interchangeably. Just say data. Everything is data. Well, technically speaking, everything is not just data. It depends on where that data is at. If it's at the internet layer, if it has an IP address, it's now a packet. If it's been transported with the TCP protocol, it's referred to as a segment. All right, let's keep moving on here in the book. We have a couple of hands-on projects, part of your assignment, but we're going to skip that right here. All right, if we go to page 230 and 231, so some information here for you guys about the application layer protocols, right? Application layer protocols, these protocols that we see here. The first one we look at is the HTTP protocol. Now, when we talk about application layer, we're talking about on page 230, it says the application layer provides network services to user applications, right? Network services to user applications. Generally, I have a slide here about that. Generally, when you talk about the application layer, you are talking about clients and servers in a lot of cases, right? Clients and servers. A client is the computer or maybe the person that's requesting information, and the server is the computer that is granting the request, all right, allowing you to gain access to what you need. So, for example, if I want to go to Wiser, right, I want to go to Wiser, I am the client. My computer, so to speak, is the client requesting access to Wiser. If I want to go and watch a movie on Netflix, my computer is the client. Netflix is the server. I need a bunch of information, and I need to go through a bunch of steps to be able to get through to Netflix, right? Like it says right there on page 231, it talks about user authentication. User authentication. When a client and a server are trying to do business, trying to interact, you have to be authenticated. What that means is you have to provide some credentials. We have to verify that you are who you say you are. For example, right here on Netflix, I heard the other day that Netflix is trying to, they want to be sure that people who use Netflix are the true account holders. So they're going to introduce some kind of code, right? So, for example, if I have a Netflix account, my wife has the same account, some people in the family have the same account, like a bunch of people have the account. So what Netflix wants to do is when you log in here, they're going to send you some code to your phone. Now, of course, if if the account is not mine directly, I'm not going to have that code. I'm not going to be able to access it. For whatever reason, Netflix wants to do that. I don't know if they started it. I don't know if they started it, but that's what they want to do. Has anybody heard about that kind of thing from Netflix? Any of you guys heard about it?
I've heard about it.
Have they started it?
I haven't noticed it because my Netflix is used throughout my household, so I haven't seen anything, but I've seen a lot about like people would just like give someone the code to log in, but I don't know if we're gonna like achieve that without.
You think it's a good idea?
I it's a smart idea on their end, but I don't know how it's achievable, especially when you could just ask the owner of the account for the code.
Exactly, right?
Yeah.
Well, that's true. Well, the whole point is when you're trying to log in, like if I was going to get into Wiser, for example, right? Wiser might ask me, they're going to send a code to my phone. So there is what you call authentication when you deal with a user and the client, right? The user or the server has to verify that this person or this device that's trying to access the server is valid, is legit, right? So that's the authentication user log on right there. There's also going to be data format, right? The data has to be formatted, like what we said here, back here. The information is data, then it goes to be in a segment or datagram. It goes to be in a packet because of the IP address. It goes to be a frame because of the MAC address. The information might change based on where it is at, right? Because at different layers, it's got a different job to do. If, for example, your information is going down the line from data to segment to packet, and it gets to packet, and for some reason, there is no IP address. Let's just say you can't find an IP address. What's going to happen to that data, Bobby?
It would be stopped right where it was because it can't go any further.
Exactly. It can't move further, right? It's like sort of, I don't know if this makes sense, sort of like you get into your car, right? And you're ready to go, you kind of clean your car up and stuff like that. Everything looks fine. The tires are good. The engine is revving, blah, blah, blah. And suddenly you just realize no fuel in your car, no gas. You're not going anywhere, right? You got to figure out somehow to go and get some gas and put in your car. So I don't know if that's a relevant kind of like thought, but yeah, if your data is moving along nicely and there's no IP address, that's it. It ain't going nowhere. It absolutely has to have that on its way. So the data gets formatted based on what it needs to do. Now let's look at a few of these protocols. Page 231, we see some information there about HTTP. So you go to your browser, just like I went here to, Wiser or Netflix. If I click on the link, if I just look at the address there and I kind of paste it here, you can see that there's the HTTPS, right? That's what we refer to as the protocol, HTTPS. Now let me see if you guys remember this here. So what's the, you have HTTPS here, and you have HTTP. So the question is, AB, do you remember what the difference is between those two protocols, HTTPS and HTTP?
Can you hear me?
I can.
Yep. So I believe the only real difference is that HTTPS is the secured. The S for an HTTPS is for secure. So that's a URL that you can go to and it'll be secure. You don't really have to worry about anything. Just HTTP is just like, I guess not as secured, but you can still access it.
All right. So you said, AB, that's the only difference. Is that that's a big difference, right?
One of the different, yeah.
Like if I went here, let's say this last page on the internet. If I go here, right, let's just say compared to Netflix or something, if I go here, well,
that one
now it doesn't mean that. Say that again.
That website, the one with like just the white screen, looks like I can get a virus just from anything.
Okay, so you mean, or you're saying that because the website is not. Yeah, go ahead.
Oh no, it just doesn't look as like compared to the other one. It just looks like it's like a completed site.
Okay. So you're probably saying or thinking that because the site is not secure, looking at this, then are you saying that just by going to the website, you might get a virus?
No, it just looks like that.
Oh,
Because
it looks,
just of the
looks
way
fishy,
it is,
right?
and yeah.
I mean, I'm sure there are a lot of, let's see, HTTP websites. HTTP website. So let's see. Okay, so here's a HTTP website, right? I think that because it's a unsecured site, doesn't mean you're going to get a virus necessarily. You can get a virus from even from a HTTPS site if it's designed that way, right? One of the differences, like you said, AB, is it is secure. So what it means is, like right here, if we go here and we click on that, where is it? Let's see. We click on the lock. What the lock tells us is, where is it? Okay, right here. The lock says, if you guys can see this here, let me see. Let me try to magnify it. Okay. All right. So right here, it says that the connection is encrypted. So with websites that are HTTPS, the connection is encrypted. And that means that the page you're viewing was encrypted before being transmitted. Now, the encryption makes it difficult, not impossible, but it makes it difficult for unauthorized people to view information traveling between computers. Traveling between computers. Now, what does that mean? That means that if you're going to exchange information with the website, that's where you might have a problem. So if I put in my information here and my information here, right, I am exchanging information, putting a username and a password and my code and stuff like that, that's when you might have a problem. So going to an unsecured site does not mean you get compromised, but if you have to exchange information with that site, then you might have a problem. If they ask you for your username and your password and some kind of a login or social security number or credit card, you probably don't want to do that at all, because now you are exchanging information, and that information, there's no guarantee that it's going to travel in a safe way. That's what that means, right? So let's move on here. So we're looking at the book. We're looking at the HTTP protocol, which is used to access data on the web. All right, used to transport data on the web, and we're on the web all the time, and so we see how that is. Now we've talked about ports, right? The port that HTTP uses, HTTP, this one here is port 80, right? Port 80 is what it's used in terms of ports, right? So when we talk about ports, we're talking about kind of like the address of that service on your computer, right? Sort of like the address. We have upwards of 65,000, right, plus different services that your computer can perform. All these different protocols, right? Emails, everything we're talking about now, these are all different services. And what we see here in this PowerPoint, these are all different services. HTTP is one service. FTP is one service. Right, FTP, I have an FTP program here. This FTP program here allows me to move files from my computer over to the server on the right side. So if you want to publish your website or some files, you want to move them to a server, you can use a file transfer protocol. That's what it stands for, FTP, file transfer protocol. You can use your FTP program, right, to move files. Right now, I'm not connected, right? If I go to my website here and I connect, suddenly you can see all my, I have a lot of files here on the right-hand side on the server. This is the server side. The right side is the server side. The left side is the like my computer side of things. So your FTP, well, we haven't come to FTP yet in that. Well, actually, we have FTP on page 232. All right, so FTP there uses port 20 and port 21. And it's used to transfer files and images and different files from your computer across to a web server so it can be published online, right? If you do website design, of any type, or you've done a HTML class, you may have used an FTP program to move your files from your computer to, maybe the server address that your professor gave you. Has anybody here used an FTP program? Brandon, have you guys done some kind of website design or something? Anybody?
I use that for Python class. We use that
Accounts class?
Python class I use for
Python, yeah.
Port
Yeah.
22.
Yeah. So you're going to use an FTP program. In fact, your assignment has a task. Maybe before the end of class we can get to that task. Has a task that asks you to do like a test. You're going to download actually a program that looks like this. This program actually, this FileZilla, and you're going to get your hands dirty with file transfer. If you've never done it before, you get the opportunity to do that. So that's what file transfer protocol is. It's used to move files from your computer to a remote server. All right, let's look at email protocols. Email protocols on page 231. Remember, all these guys function on the application layer because you're dealing with applications. The FTP needs an application like FileZilla to get its work done, right? Your HTTP needs an application like a web browser, right? Like a web browser. This web browser here works with the HTTPS, and this particular page works with, this page works with HTTP. And that's how you can access websites, web browsers. If there was no web browser, it might be a serious challenge to get to any website. All right, so we're looking at the different protocols that work on the application layer because they deal with applications, right? Same thing with email. So email has a couple of protocols that are attached to it on page 231. POP3 is used to download email, right? POP3 is a protocol that's responsible for downloading email. So you click on your email, or for your email to come through to you, you need POP3. Now the other one there, SMTP, that is for sending email, right? So POP3 is to receive. SMTP, you're going to see that question a bunch of times. POP3, or some people say POP3, is used to retrieve email, and SMTP is used to send the email. And SMTP works on port 25, and POP works on port 110, right? Port 110. So we're looking at the book on page 231 and page 232. Okay, so when you send emails and receive emails, if you have ever had to configure a mobile phone to be able to send, maybe you have a Microsoft Exchange email, and you have to set it up manually. When you set it up manually, you're going to see that there's some places where you got to include, you got to ask your IT people, what's the POP information? What's the SMTP information? All that stuff there is required for your email to work. Sometimes your email you might be able to receive and not send, or you can send but you can't receive. There might be a problem with the setup of your POP or SMTP. So SMTP there stands for Simple Mail Transfer Protocol, and POP is Post Office Protocol. So all these guys work on your application layer. Let's move on a little bit here. Let's look at let's look at DNS. Let's look at DNS, domain name system or domain name service. Pratik, have you heard about DNS? Do you know what DNS is all about?
I've never heard of it, but I only know what domain is.
Okay, so what's a domain? When you say domain, what's a domain?
It's like the website, like HTTPS or like google.com. Like I'm .com at the end, or like edu or .org.
All right, so like some of the ones I have on the screen now.
Yeah. Like the last .edu or .com or .org.
Okay. So all this here are domain names, right? umb.edu, that's domain name. Netflix.com, Google, Amazon, those are all domains, right? So now, what happens when you want to go to UMB? Pratik, you want to go to the website. What do you type in the browser?
UMB, www.umb.
Okay. Now, when you type UMB or www.umb, and then the website just appears, right? Like, boom, the website is right there.
Mm-hmm.
Well, here's what happens on the back end. Computers and servers don't understand English or words. They understand numbers. They work with numbers. So in that DNS system, let me pull this down a little bit. In that DNS system, the domain name service, domain name service or system, right? It's like a database. In that database, you have your domains, domain names, and you have the corresponding IP addresses. So let's just say, just going to make this up. Let's say the IP address for UMB is 110.23.4.13, for example, right? What happens is the domain name system, when you request that website, goes through the browser, right, looks at the entry for UMB and looks at the corresponding IP address, and that's how it locates that server and the files that you're looking for on the server. It has to look at the corresponding IP addresses. Same thing here. If I go to Netflix and it has to look at the IP address for Netflix, let's say whatever it is, just making that up. If that is the IP address, it has to, when you type in netflix.com, it looks for the IP address and fetches it for you. Now, here's an interesting question. Why do you think that is? Why does it, look for a number and doesn't use the name? Shall we? Why do you think it does all that, looking at the, why do you think that is? You have any idea? Shall we?
Not sure, Professor.
Okay, let's try it this way, shall we? Do you have a phone? Like a cell phone?
Uh-huh.
What?
Yeah, I have a cell phone.
Okay. About how many contacts do you have on your phone? Just a general number.
Like 8.
8 or 80?
8.
8, okay. Now you have 8 contacts on your phone. And you have their phone numbers, right?
Yeah.
Okay. So shall we tell me how many phone numbers do you remember, like in your head?
None of them.
Oh, none of them, right?
Except myself's.
Okay, you know your own phone number.
Yeah.
Okay, well, I'm sure that's how most people are. But I'm sure you can tell me, well, maybe I have my mom, maybe my dad, my friend, the guy that works at the office, all kinds of people. You can probably describe the people you have on your phone, but you don't remember their numbers. Well, that's the same thing when you're dealing with, because human beings, right? You and I are not very good with a lot of numbers, very complicated numbers. So we're better with names. Mm-hmm. And for that reason, is why you have the domain name system, because you're not going to remember all these IP addresses, 110.23.4.12, that you want to go to Netflix, just using this as this is not their IP. 89.12.5, who's going to remember all that stuff? So the domain name system helps us to get the job done. You remember the name, you remember Netflix, you remember Google, Amazon, Harvard, UMB, Sesame Street, whatever you want to go. You remember that.
Mm-hmm.
You put that in the browser does the job. Working with the DNS protocol, it looks at the database, right? Looks for the IP address, and that's how it finds that information. So computers do a better job with numbers, just like you and I. We can't remember all the IPs, but we can remember the names. So the domain name system. Go ahead.
I have a question. Like when you type umb.edu, the computer will ask for the DNS for the IP address of the website. But after you entering on the umb.edu, like for example, like you click on the link on the UMB, so still does computer still ask for the DNS for the?
No, it doesn't ask you. So if I go here and I put in UMB, right, .edu, the computer doesn't ask me any question. Once I hit enter, it just gets me the website.
Yeah.
But what happens is, say it again.
Yeah, I mean, after you entering the website, like when you click anything like search or you mess, like, you
mean like here?
Yes, but the URL will change. Like,
I don't understand. I don't understand your question.
I mean, like the DNS provide you for the IP address of the URL you entering, right? But
yes.
But after you click any link on this website, will the
oh, I see what you mean. You mean like if I go to admissions and age, for example, right?
Yeah, you can see the URL is changed.
Okay, I see what you mean. Well, remember, we're talking about a domain. So the domain is like when you go to your house is a domain. Now, once you get into your house, you can go to the bedroom, you can go to the bathroom, you can go to the kitchen, you can go to the basement, right? But they're all in your house. Do you understand? So once you get to the domain, then you can do anything you want to do on the domain. It's not going to, you don't have a different IP for every link. You have one IP for the domain. And when you're in that domain, you can go to any of the links. It's still on the same domain.
Okay.
Make sense?
Yeah.
So it's the same domain. The domain doesn't change. The same IP, the same domain. All right. So that's a great question, though. That's a great question. All right. So let's move on here a little bit. Here's another protocol. Okay, well, let's look at two more protocols here. Let's look at the DHCP server, the DHCP protocol. That is one of the protocols on the application layer, DHCP. Again, I'm going to ask if anyone knows what the domain DHCP refers to. Sasha, what is DHCP? Sasha, are you there?
Yes. Hi.
So have you heard of DHCP? Do you have an idea what it is?
No.
It sounds like you kind of know what it is, but you're not sure.
No, I don't know.
Okay. Let's look at what, Summer, have you heard of DHCP? Do you know what it is?
I've definitely seen it before, and bring up command prompt. When we would do the IP config, I know it comes up in there, but I don't know what it means.
All right, let's take a look here. ipconfig/all. All right, so you go here. Let's go to my Ethernet connection here. Right here. Okay. Sasha, do you see this here? Ethernet DHCP enabled?
Yes.
Actually, is it this one? I think it's this one here. No, DHCP should be somewhere there. Oh, right here. This is it. This is it right here. Okay, so DHCP, according to what we see in the book, do they have? Yeah. So in the book on page 232, 233, it says that a DHCP server is basically responsible for managing a block of available IP addresses. So whatever network you are part of, so right now you're at home or you're at the office or you're in school, wherever you are, and you're connected to the internet, you're part of a network, and that network is responsible for giving you an IP address. Remember what we said earlier, if your information is flowing down the line and it has no IP, boom, that's the end, nowhere to go. So the network that you're a part of is responsible for giving you an IP address so that you can get online and do what you need to do. There's a set of IP addresses that basically has been allocated by your network, right, to your LAN, your local area network, for you to be able to get online. That's what DHCP does. It's installed on a server. That server's job is to give you an IP address. Now look at this here. Sasha, let me stay with you. So you see this line here, right, Sasha?
Yes.
Now it says lease. What's a lease? It's like, you have an apartment or, you get a car, and, after a certain amount of time, your lease will be up. And you either renew your lease or you move on. So here it says the lease, basically my IP address was leased to my computer, right, on Sunday, March 28th. Now, the lease for my IP address expires today. Is this today? No, not today. In April 6th. All right, so what's going to happen to my computer after April 6th? Sasha? Is that like bye-bye to the internet for me? No more Zoom? What's going to happen?
Get a new one.
You get a new one?
I'm not sure.
Azim, what do you think? Am I going to get a new one, or, is my computer like history now? I have to just, who knows?
You can, it doesn't really matter.
We're not hearing what you're saying. Could you speak a bit louder?
Yeah. What was the question?
Say it again.
What was the question?
Didn't you just answer the question? I thought you just answered it.
Oh,
Are you asking me again what the question is? I thought you just answered it.
No, I was just making sure it was a question.
So what happens when the lease expires on April 6th? On April 7th, I have no more internet, right?
No, it should still be going.
How do you know that?
Don't know.
It says here that it expires.
Yeah.
So what's going to happen on April 7th?
I don't know.
Okay.
The DHCP will give you a new address.
Change.
Well, you're right. You see, the job of the DHCP server is to manage IP addresses and to list them out periodically. It does that because you have a certain number of IPs that are basically for your network. A certain number of IPs for your network. Now, you don't have to have the same IP all the time. You may, but you may not have the same IP all the time. So let's say you shut down your computer, and let's say you have visitors in your house. You have your cousins or you have your parents' friends in your house, and everyone has a device. If some devices are shut off and some are shut on, the device IP addresses might move around. Now, it doesn't matter if you have the same IP address. In fact, you don't even care about what your IP address is. I mean, before this class, I'm sure it never occurred to you that there's an IP address that may change. Who cares? You don't care about that stuff. I mean, if you're an IT person, of course, it's going to mean a lot of, that it's important to you to know that and what's going on. But, in actual fact, it doesn't really matter what happens. But the DHCP server will list you that IP address, and once it's expired, automatically it renews it, like all the time. You never even have to check. You don't have to sign up. You don't have to pay for it. You don't have to call a number to get it renewed. It does it automatically. Now, if your computer gets shut down, DHCP server might just take your IP address temporarily and give it to somebody else, a different device. Once you power your computer back on, it gives you another IP address. As long as you want to go on the internet and you're part of that network, the IP address will be given to you. If you get your laptop and you go to school, or you go to the airport, or you go to a friend's house, that network where you are at is going to give you an IP address. That's the job of DHCP server, to make sure that you have an IP address, right? IT people are very concerned about the DHCP because sometimes things don't work as smoothly. We need to troubleshoot. But that's what a DHCP server does, right? When you see a lease obtained and the lease expires, it doesn't mean that your computer is going to shut down. It's going to be renewed automatically. But that is as long as you have a DHCP server present, right? And you always, as long as you're on the internet, you know you have a DHCP server somewhere with Comcast or with Verizon, or if you're on campus at UMB somewhere. It's all part of it. Okay. Let's go on in the book. There's a few more protocols there. We can't go into everything. The remote desktop protocol on page 232, that's also an important protocol that is used by IT people. So RDP. If you're an IT person, or when you become an IT person, this is your remote desktop protocol. In fact, all the stuff we're doing remotely is in most cases aided by the remote desktop protocol, right? The ability to see somebody else's screen in a remote setting is remote desktop protocol in action, right? Now, more importantly, on a Windows computer, you're gonna see this little tool here, right? This tool is used in a network to connect computers that are all in the same network. So if you and I were physically in the same office building, and I was your IT person and you called me, I need to know your IP address, right? I put your IP address in here and I hit connect. It's going to connect me to your computer. I think I've showed you guys this a few times. So let me just show you quickly again. I have a connection to one of my computers on campus at UMB. The connection is all set up, so I'm not going to spend too much time talking about that. But right here, if I put in all my information, it should. Oh, I didn't do that correctly. Okay, so I use PuTTY. Some of you might use PuTTY in your other courses, but I use PuTTY to get in there. And once I get in there, now the server assumes that I'm now in that domain, like I'm physically there. So I can go in there, use my remote desktop protocol, and in just a couple of seconds, is going to log me in to that computer. This computer that I'm logging into right now is physically on campus, right? So thanks to the remote desktop protocol, it's used for connecting computers that are within the same network. All right. So that's just a quick demonstration there of. So everything we do now with all this remote stuff, you know, the ability to see somebody else's screen remotely, that's all thanks to RDP. Let's see a couple more things here in the book. All right, so right under your desktop, sorry, your DHCP. Well, we're going to talk about this more in chapter 6, but you see there on page 235, it talks about automatic private IP addressing, APIPA. Now, APIPA is an important concept because APIPA is what works when there is no DHCP. Like I said, DHCP's job is to give you IP addresses, right? Bobby, do you see that information about APIPA on page 235?
Yep, I see it.
Okay. So DHCP's job is when you've got all this network going on, it gives you an IP address. But if for some reason you're not in a network, let's say you're just at home by yourself, you go to your basement, you know, you grab a computer and you turn it on. And you grab a second computer and you turn it on. No internet or anything, just two standalone computers. And you directly connect those two computers, right? Like you use a internet cable or Ethernet cable, and you hook up those two computers. Brandon, do you think those two computers are going to be able to talk to each other?
Probably not.
Listen to what I said. Two standalone computers, no internet, but you take an Ethernet cable and you hook it up directly between those two computers. Are they going to be able to communicate? Brandon?
I don't think so.
Don't think so. AB, what do you think? Are those two computers going to be able to talk to each other in that kind of setup?
Can you what type of setup? The layered architecture setup?
What do you mean layered architecture? Did you hear the last thing we just talked about now?
A little bit.
What part did you hear?
Just that you're asking him the question of what do you think if it'll be in the same ports or not?
No, AB, you're not paying attention to what I just said. I need you guys to be paying attention. If you can understand what I'm saying, just tell me to repeat it. I give an example. You have two standalone computers, no internet, two standalone computers. You take an Ethernet cable and you hook them up directly together. Can those two computers communicate with each other?
No.
Why not?
From like one Ethernet cable attached to another
directly,
PC, just
yes.
like that.
Directly, yep.
I
directly.
wouldn't think so because there's nothing else that's connected to a router or anything that's giving like internet access.
Okay. Summer, let me go back to you. Would those two computers be able to talk to each other?
If they're connected, I would believe so.
One more person. Eduardo, what do you think? Would those two computers be able to communicate with each other?
Yeah, I honestly, I don't know.
Okay. So you have two computers, you power them on, you take a cable and you directly connect them, together, right? Direct connections. Your cable is what creates the connection. So that is how you get them to talk. You have a cable that connects them together to talk. Now, when you talk about routers and all that switches and routers, that is if you want to connect to the internet. You don't have to connect to the internet. You can have two computers or three computers or five computers directly connected together, and those computers can communicate amongst themselves. They're not going outside to somebody else. They're talking to amongst themselves, all two or three or four or five computers, because you have a cable that connects them together. So all networking is not about internet. Like, you want to go on Amazon.com or something, or you want to go on Netflix. No, you might just want to have an internal office setup that has nothing to do with the internet, with going outside. You want to be able to, you may want to keep all your communication restricted between these few computers. Now, the question I asked earlier, I think it was Brandon, talking about APIPA. Now, when you have no DHCP, because if you have this direct connection amongst computers, there is no DHCP. Obviously, you have no network. Like, you have no network server. You just have a direct connection between two computers. Well, those two computers need an IP address to communicate. Now, you might wonder, how are they going to get an IP address when there's no server? No server, no DHCP. How are they going to get an IP address? Because without an IP, no two computers can communicate. So we know that. So how did they get an IP? No network, no Comcast, no Verizon, just two computers directly. Well, back to that term or that word we see on page 235, APIPA. What does it say there? APIPA on 235, an address in the APIPA range is assigned automatically to an APIPA-enabled computer when an IP is requested, but no DHCP server responds. Josh, how does that sound? Does that kind of make sense to you, or at least based on what he says here?
Right, so it's like the base case if there's nothing to import.
Say that again?
Like it's creating like the base case in case there's no IP address found.
Exactly. When there's no IP address found, because obviously when two computers are directly connected, there's no network on the outside. You're not connected to your home network or anything. Just these two guys directly connected together, right? APIPA has to replace DHCP. And what APIPA does is it gives those two computers, it automatically generates IP addresses so they can communicate exclusively between those two or three computers that are directly connected together.
Is APIPA come from the NIC or somewhere? Like,
that's a good question.
Yeah,
that's a great question. So APIPA, right? APIPA is all part of your NIC card, absolutely, right? It is attached to that whole Ethernet NIC system. So if you took out your NIC card, right? You can't even. You can't do anything at all. Absolutely nothing, right? So, but the APIPA is all part of that system. So you have a NIC card, but you have no DHCP server. APIPA is going to kick in and supply an IP address so that those two computers can communicate.
Can you reset your IP address? Like you just set your private IP address.
Say it again.
Can you just set your private IP address? Like no matter
Okay,
what
so
people does,
yeah.
but you just set it.
Okay, so let me answer that question. That's the last thing, and then we're going to wrap this up. So maybe what you're talking about is a static IP. So your computer, just like I said, your computer, the IP address may change, right? There's no guarantee that you're going to have the same IP because, it doesn't really matter. But if you have a server, like you have a, umb.edu, Netflix, Google, or stuff like that, well, those servers need to remain permanent. We need to know what the address is all the time, right? So in here, you have an option to, you see what it says here, obtain an IP address automatically. If you don't want that and you want to obtain your IP address, like you want a static IP is what we call it, a static IP, right? A static IP is mostly for servers, right? On servers, you have a static IP, and for example, here I could put an IP here. Just make one up right now. You can have an IP address here that will never change. But you have to talk to your DHCP. You can't just do that by yourself. It has to be a valid IP address. But once you have a valid IP address, you can set that up on a server. It's never going to change, so that whatever the server has to communicate with, right, the IP address does not change. It's different from a client computer that may change IP addresses through the DHCP server, right? DHCP server gives you addresses randomly, gives you a lease, takes out the lease. But if you set up a fixed or a static IP on a server, it never changes. So every time you're communicating to that server, you know what the IP is. All right. So we're going to finish this up on Thursday. So let me just end this recording now, and we can do the attendance and see if you guys have any questions.